everybody, and welcome to Cranky Calculus. We're going to go ahead and cover some curve sketching here. It's a really important topic in terms of understanding what the heck is going on when we do these tests for increasing, decreasing concavity, relative maximums, minimums. Even looking back at end behavior and seeing what that looks like with right end behavior, left end behavior, vertical asymptotes, all that good stuff. Talk about x-intercepts, y-intercepts. We're just putting everything together here so that we know how to sketch a curve. Even though this is not tested on the AP exam in terms of testing the actual sketching of curves, you will be tested on all these type of topics. And as we go through this, I'm going to justify everything. So make sure that you pay attention to the details here so that you can get full credit when you're doing this in class. Make sure you like and subscribe for more videos like this, and don't forget to check out the absolutely free content we have here in the description with the free set of notes that you can use and the keyed notes as well. We're going to start off here with this function, and we're going to kind of go through everything as we go through it here. Let's start with the signs of f of x on the domain. What we're going to do here is we just got to figure out when the heck this function is equal to 0, and then we can figure out when we're positive and negative. So when we set f of x equal to 0, that's going to happen at x equals 0, because it's already in factored form. We're going to have 0 and 4 right here. So if I make just a little bit of a sign chart here for f of x, 0 and 4. My right end behavior, if I were to plug in any number greater than 4, you would get that we're going to end up at positive infinity. And at the factor x minus 4, we're going to change signs because we are going to go through the x-axis because we have a degree of 1 on that x minus 4. And then the x to the 1/3, that's an odd degree, so we're also going to change signs again. So we're changing signs right there. So we're going to be f of x is positive on the interval negative infinity to infinity, not infinity, what am I thinking? Negative infinity until 0, and from 4 to infinity. And f of x is going to be below the x-axis between 0 and 4. Okay? So before I get to the calculus stuff, let's just keep going and roll along here with some pre-calc stuff. Let's do the x-intercept. So to find the x-intercept, I already did that heavy lifting here. That is when f of x is equal to 0, and that's going to happen at x equals 0 and x equals 4. And what is f of 0? F of 0, by the way, is 0, and f of 4 is also 0. So that's how we know that these are my intercepts. So I'm going to have x-intercepts at 0, 0 and 4, 0. Moving on to y-intercepts. That's when I set x equal to 0. And you're going to get another 0. So we're going to get set equals, so f of 0, which I have read above, is 0. So we have an x-intercept at 0, 0. As we look at vertical asymptotes, that's going to happen whenever I have a ratio. This is not written out as a ratio, so I'm not going to have any vertical asymptotes, because we only have vertical asymptotes when we have a ratio and the denominator is equal to 0. So we're going to have none here. Vertical asymptotes, your look at denominator, and there is none here. Horizontal asymptotes, that's going to be the end behavior. So we're going to look at as x goes to infinity of f of x. That is my right end behavior, which I made that sign chart right up here. You can clearly see that we're in positive. So there is no horizontal asymptote as we go out to the right. If we're looking at the left end behavior, so we're going to look at negative infinity of f of x. It's also going to reduce to infinity, just for me looking at that domain right there. So before we do any, this is all pre-calc stuff that you should know. We can kind of get an idea what the heck this graph looks like, and got our x-intercepts, got some points, and I'm real quickly going to plot those points right here. So I have them. So I have 0, 0. Do some tick marks here, and then we have our 4, 0. Now for intervals of increasing, decreasing, this is going to do some calculus here. So I need to find out what f prime is. So f prime of x, this is going to be some product rule here. So the first is first. So we're going to get 1/3 x to the negative 2/3 times x minus 4 plus x to the 1/3. The derivative of x minus 4 is just going to be 1. So it looks like this times 1. And I'm going to find the GCF of that so that I can set f prime equal to 0 for my critical point. So it'll help me find out where if I'm increasing or decreasing. So f prime of x, if I have a GCF here, take out the smallest of the powers. I have a x to the negative 2/3 That's going to leave me with a 1/3 x minus 4/3. Oop, I don't know why I ended that parentheses. That's the first term. And then plus x. Yeah, that distributes all the way through. And if you actually distribute this, you will get this exact same thing that we have here from just above. Yeah, I'm just double checking everything. Everything looks good. Let's play around with this a little bit. Let's go ahead and make this a 1/3. Actually, I'm going to get 4/3 x on top minus 4/3. And this is all over x to the 2/3, which is equivalent to, if I have a 4 on top, 4x minus 1 all over 3x to the 2/3. Okay, what I want to do here is I want to set that equal to 0 so I can find my critical points. I do have critical points here where I set the numerator equal to 0. Also set the denominator equal to 0 because that's going to give us critical points as well. So you notice here we're going to critical point at 1 and a critical point here at 0. So make my sign chart here. And I have 0, I have 1. My right-hand behavior for my derivative here is going to be positive. At 1, I'm going to change signs. But at 0, I'm actually going to keep the sign there because I'm x to the 2/3 for my 0 factor. And that's going to actually bounce off the x-axis. So with this sign chart, I am increasing on 1 to infinity because f prime is greater than 0 and f prime is continuous. And that's why I can include that 1, is because we're continuous at x equals 1. And we're going to be decreasing on negative infinity until 1. Again, we're going to include that 0 because we are continuous here at 0, because if you look up here for our domain, we have no issues with continuity whatsoever. So we're going to, I'm going to include that 1 because f prime is negative and f prime is continuous at x equals 0 and x equals 1. So that's why I'm including 0, that's why I'm including 1. Okay? With that, I'm actually going to skip down here. I'm going to go ahead and go to relative maximums, relative minimums, in the bottom part, because I have everything here. If I were to draw the behavior of the function here in orange, it looks like this: decreasing, decreasing, and then increasing. I actually have a relative max, or sorry, relative min rather. So I have a relative min at x equals 1 because f prime changes from negative to positive. I keep saying the wrong thing here. Negative to positive. Okay? And I don't have relative max. That's all I have here. Just for fun, I can find that value at 1. I can find that because this is pretty easy to plug in. I can find f1. If I were to solve for f of 1, I would actually get negative 3. So this is going to give me the coordinate point 1, negative 3. You know what? I just need to learn how to write better. Negative 3. There we go. So I'm real quickly going to go over to my graph right here and go ahead and add that on there. So 1, negative 3. So we have a couple more points here on my graph. And let's go ahead and start to connect the second derivative, and then we'll sketch this thing to finish this question off. Let's go ahead and talk about now our second derivative. So in order to do our second derivative, I need to look at probably the easiest form for the first derivative. I think the easiest form is actually going to be this ratio right here. So I'm going to use the second derivative based off of this guy right here. So second derivative is going to be low d high. So that derivative of the high is just going to be 4. So it's going to be low 3x to the 2/3 times the high, which is 4, minus the top, which is going to be 4x minus 4. I'll just distribute that. And then the derivative of the bottom there is going to be 2x to the 1/3, negative 1/3, all over the bottom squared. I'm going to clean this up a little bit here. Looks like on the top, I can actually factor out a 4x to the negative 1/3. It's going to leave me with 3x for the very first term, and the next term I have x minus 1 times 2, so it's going to be minus x minus 2. No, sorry, it should be 2x minus 2. So 2x minus 2. I'm going to distribute that 2. Sorry, I'm doing a lot of mental math right here. I took out the 4, which is x minus 1. Distribute that. It should be 2x minus 2. So it's actually going to end up being a plus 2 all over this 9x to the 4/3. One last final cleanup. I'll do it right over here. Is I'm going to end up with the 4 on top. I'm going to have an x plus 2 on top. And then I'm going to move that x to the negative 1/3 to the bottom. So I'm going to get 9x to the 5/3. Just a little bit of algebraic cleanup. And then when we're here, let's go ahead and make our sign chart. I'm going to have it kind of sort of line up here with my first derivative. I have a potential point of inflection here at 0 because the denominator equals 0 there. And then I also have another one at negative 2. So I'm going to put that right over there. All right, so if I look at my right end behavior for my second derivative, I'm positive because my x's are all positive. And then I'm actually going to change signs at both of these because they're both odd degrees or odd fractional degrees. So I'm going to change signs. So I'm going to look like this. Okay, so with this, I'm concave up. I don't know what's going on right now with my... I'm concave up. There we go. Negative infinity to negative 2, and from 0 to infinity. Because the second derivative is positive. I'm going to be concave down from negative 2 to 0. Because the second derivative is negative. I can use this information now, come down here, find out my point of inflections. I'm going to just stick with the x values because if I'm looking ahead, it's going to be really hard to plug in the negative 2 back into my original function here because I have the x to the 1/3. Kind of makes things a little tricky. So let's just do x values only. So I have an inflection point at x equals 0 and negative 2. I guess I should have gone in order there. Who cares? Because f double prime changes signs. Make sure that we have a point of inflection because we're changing signs. Now, I'm going to use all this information to go ahead and start talking about how to graph this, and let's wrap this thing up. One thing I see here that's going to be a little weird is looking that our derivative here is not continuous here at 0 because the denominator is 0. So the original function itself is continuous, so f is continuous, so the derivative is not. What does that mean? It means we're not differentiable at x equals 0. Not because we're not continuous, but because of one of two reasons. Either we have a vertical tangent, or because our derivative changes completely at 0. So it can be from negative to positive, positive to negative of some sorts with a cusp or corner is really what I'm trying to get at. It's just a sharp turn. So this right here, I'm going to tell you right now, we do have a vertical tangent at x equals 0. Reason being is because since we are continuous, our derivative does not change signs at 0 where we're supposed not to be differentiable. When we don't change signs on that sign chart like this, it means that we do have a vertical tangent because it means that we do have a vertical asymptote on the derivative function itself where we're going in the same direction. So it's a vertical tangent. So I'm going to have a vertical tangent here at 0. Let's go ahead and finish graphing this thing. You can clearly see from my original sign chart in green, we're going to go positive, negative, positive. You can see that from the points that I have on that graph. We're going to go from decreasing the entire time until I hit this second dot, and we're going to be concave up and then change to concave down. So it's going to look kind of weird here. So I'm going to just do kind of two things over here. Usually I'd plot my other point for this, and it's really hard to plot that. F of negative 2, it's going to be negative 2 to the 1/3, which I don't really know what that value is. It's pretty small value, times negative 6. I don't know if it's above negative 6, below negative 6, but anyway, let's just say it's right here. I'm not going to plot a vertical point for that. So we're going to go from concave up to concave down Okay, without having a vertical tangent, so it looks something like this. Some concave down. And then at 0, I'm going to change back to concave up the whole time. And then I'm going to be increasing concave up. And it looks kind of sort of weird because I'm not a really great artist. I'm going to do, now that I kind of had an idea right here, I know that's a vertical tangent, I'm going to do a slightly better job at this. I have the ability to erase. I thought I had the ability to erase. There we go. So I'm going to quickly fix that. Draw this a vertical tangent like this. There we go. That looks better. The sketching part, whatever. Like, you can't do it, whatever. It's not the end of the world. Just understand how everything works. Everything we have here in the green up here to the basic pre-calc stuff, to the first derivative stuff, all in blue, all the way down to the second derivative stuff in red. You need to be sharp on that stuff, and make sure that you like and subscribe so you can see more videos, more stuff for justifications, and everything to help you out here with calculus here at Cranky Calculus.